Look, to define beauty is an almost impossible task. There probably are as many definitions as the number of people you're going to ask to define it. What I tried to do in that book, and that in itself was hard enough, was to define, well, to try to narrow down a little bit. When does a physicist talk about a certain theory in physics specifically as being a beautiful theory? So it was not a definition of beauty. It was a definition of beautiful theories in physics. And even that turned out to be very difficult, because if you, again, look at many scientists even who talked about beauty in physics, they use many, many words like harmony and balance and all kinds of words like that. And I tried to somehow focus on the things which I thought were absolutely essential in a way. And I ended up with three concepts, as you mentioned. I mean, one was symmetry. And symmetry I put in because, most of the fundamental laws of physics, they have a symmetry associated with them. In fact, all the laws that we call conservation laws, like, people heard about conservation of energy, conservation of momentum, and so on. All of those conservation laws stem from certain symmetries. For example, conservation of momentum stems from the fact that the laws of physics are symmetrical under translation, which means they don't change from place to place. We see the same laws that we have here on Earth apply in a galaxy that is 1 billion light years away. The same laws of physics apply. Conservation of energy comes from the fact that the laws are symmetric with respect to time. The laws appear not to change with time, and so on. So symmetry is really, if you like, almost the source from which laws of physics stem. So that was clearly a necessary ingredient. The second concept that I introduced was simplicity, which I meant in the sense of reductionism, namely that you want theories in physics with the minimum number of variables or equations to describe as many as possible phenomena. For example, every physicist will tell you that Maxwell's theory of electromagnetism is fantastically beautiful because with just four mathematical equations, he could explain all the classical electromagnetic phenomena. Think about this, there is so much in electromagnetism, all explainable with four equations. That is considered absolutely beautiful. Things like Einstein's theory of general relativity is thought by some to be the most beautiful theory of all. It's first of all, it has lots of symmetries built inside it, but also, with this one theory, you explain everything that's related to gravitational force, and so on, whether it is tides in the ocean, or it is the planets moving around the sun, or how the universe as a whole behaves and all that. So all of that is there. So that was the concept of simplicity. And finally, there is the concept that probably least number of people know what that is, which I call the generalized Copernican principle. And what do I mean by that? Starting from Copernicus taught us that we, or the Earth, are nothing special. We're just another planet orbiting an ordinary star, and so on. Since then, we have gone through 4 more, if you like, Copernican revolutions. Astronomer Harlow Shapley showed that in our own Milky Way galaxy, the solar system is not at the center, is some 2/3 of the way out. So again, nothing special. After that, Edwin Hubble and others have shown that there are many galaxies. By the latest estimate, maybe as 2 trillion galaxies in the observable universe alone. The Kepler Observatory has shown that there are terrestrial planets a bit like the Earth in our own galaxy, in numbers like from a few hundred million to a billion or so. So in that respect, also we're nothing special. And finally, perhaps, there are some speculative theories now, which is called the multiverse, which maybe even our entire universe is just one member of a huge ensemble of universes and so on. So in all of these steps, we have kind of progressed to a situation where the theory is not dependent on us being there or the Earth being in a special location. So, and we would like most theories to do that. I should mention something though. The last step which I mentioned, multiverse, that maybe there are many universes, that's maybe where Copernican humility meets its limit. Because it is possible that in these many universes, the laws of physics are different, or the values of constant of nature are different, so that, for example, complexity and life could not emerge in them. So our universe is somewhat, if this ensemble exists, our universe may be special in this ensemble, not quite the same as everything else. So to give you a somewhat silly example, but which exemplifies this, is suppose you wake up in the morning and you wonder, what am I? Now, if you just went by statistics and by not wanting to be special at all, you would say I'm an insect, because insects are the largest biomass on Earth. At any given moment, the estimate is that there are about 10 to the 19 insects. That's one followed by 19 zeros of insects. So, just speaking like that, chances are you are an insect, yes? But why is it not true? Why is it false and you are not an insect? Because merely by wondering about the question, what am I, you already distinguished yourself as being special and not an insect. Yes? So, yes, you want this generalized Copernican principle to be nothing special, but it does hit a limit at the end. So, we now hit that limit, for example, in this example.
Yeah, no, that's really fascinating. You also dismiss, I suppose, the value of elegance, which is another sort of criterion that a lot of scientists bring up as not being particularly necessary for a definition of beauty in scientific theories, right?
No, I don't dismiss it. Elegance is brought a lot in mathematics. People talk about elegant proofs. There are proofs that are shorter, usually, simpler, somewhat surprising, and so on. Now, in physics, I think that this concept of elegance is captured by a combination of simplicity and symmetry. So this is why I didn't bother to list it separately, but elegance is certainly something very nice to have. And in mathematics, it's there definitely are problems where the proof is more elegant this way than it is that way. You find the answer in more elegant ways, and so on. So it's an important concept, but I wanted to be as reductionist as possible in my definition. Hey
everyone, thanks for watching. If you liked that video, please hit that thumbs up button and share it with your friends. Also, please take a second to hit the subscribe button because it really helps us out.